Welcome back to Algebra Skills. Today we'll be talking about rates of change in the difference quotient, which is a big topic in Calculus 1. Remember, these problems are all for practice. You'll have to do the Algebra Skills assessment or evaluation for a grade later on. Let's talk about the average rate of change. The average rate of change of a function from some input value x equals a to some other input x equals b is given by this formula. I'm actually going to rewrite it as f of b minus f of a divided by b minus a. The equation works out exactly the same way, but we're going to be using this one for the rest of these videos. If we evaluate this function at b and at a and subtract that, and then divide by the difference b minus a, this tells you how much the function needs to change on average to get from the first point to the second on our graph. Let's take a look at an example. Let's say we want to find the average rate of change of the function f of x equals 3x plus 1 going from x equals 1, that's a, to x equals 4. This is going to be our b. In this case, remember our average rate of change formula is f of b minus f of a divided by b minus a. And so if we plug in these values, that's f of 4 minus f of 1 divided by 4 minus 1. If we evaluate this function, we can see that f of 4, that's 3 times 4 plus 1, which is 13. f of 1, that's 3 times 1 plus 1, that's 4. And so in our numerator, we can write f of 4, that's 13, minus f of 1, that's 4, all divided by 4 minus 1. Doing this math, 13 minus 4, that's 9, 4 minus 1, that's 3, and we get our final answer is 3. Now, it's not a coincidence that the slope of this original function was also 3. In fact, if we calculate the average rate of change of any linear function, that's just going to be the slope of that function, because the slope is the only thing that causes the value of the function to change. Let's try again with a quadratic function. In this case, we've got the function g of t going from t equals negative 1, that's this point here, up to t equals 2, that's this point here. Going ahead and doing some calculations, let's go ahead and find g of negative 1 first. We can see that that is 4 just by reading it off on the graph here. Similarly, g of 2 is going to be 1, which we can again see just by reading it on the graph here. And therefore, our average rate of change, that's going to be g of b minus g of a. Notice we've changed the function name, divided by b minus a. And plugging everything in, that gives us 1 minus 4 divided by 2 minus negative 1. So we get negative 3 over 3, which is negative 1. We'll notice that we have a negative number because our second point is actually lower down than our first. If we were to connect these points with a straight line, that line would have a slope of m equals negative 1. That's what the average rate of change means.